Hey, welcome back to the Build Show. Steve Basic Architect here. We're down here with Shoreline Builders, another great project that they're doing. And today we're going to talk about big open clear span rooms. So one of the common requests that I get these days are, hey, can we have a big multifunctional room where the kitchen, the dining room, and living room are one giant room? So I'm standing in this room. It has a 22-foot width, and we're probably on the order of about 46, 48 feet in length here. So it's a giant room. We're talking, probably somewhere around 1,200 square feet of space for those three rooms. And as you can see behind me, we have these four beautiful sliders here, and we have that ocean view right out to the harbor. So, we knew immediately to capture that, but having that large great room, well, it sets us up to do specific things for the framing package. So we're talking about floor framing today, and the floor I'm standing on, as well as the floor above me here, they're both what we call clear span. So there's obviously no supports in here because we have this one giant room. And so we're using an engineered floor joist. You can see up there. They're 16 inches on center. They're 14 inches deep, and they have a 3.5-inch flange. One of the other things that you can see up here is you notice that we have a row of blocking right here that goes down through the whole system, and then we have a second set over here. So we basically divided that clear span into thirds. And what the blocking does is that sets up this one-way system where the joist, and one-way system I mean by having a support on each side with a simple beam in the middle. The minute I inject this lateral set of blocking, it turns that floor system into a two-way system, right? So there's a lot of options that can come into play to deal with clear spans. And this one here, simply go across, but there's different ways that you can achieve strength in those floor joists. So we'll go back to the studio, I'll pull out the framing plan, and we'll have a really quick discussion on what are some of those options, how do we deal with getting the strength that we need to meet this 22-foot span. So I'll see you back at the studio. Hey everybody, hopefully you enjoyed that quick trip out there to the job site, visiting one of Shoreline Builders' projects. Great guys to work with, been working with them for almost 30 years. Every project's a treat and a privilege to work with them. But anyways, as you saw out there, we talked about those nice open span floor frames. Broke out the floor plan and the floor framing plan for that project here. Got my good friend Big Red. Time to dive in and talk a little deeper. All right, so you can see here, threw down the floor plan. This actually has some of the lighting, but you can see I was standing, somewhere right there when we were filming the on-site stuff. But you can see here, we get a lot of calls for this type of environment now. These rooms that are, 22 by 50-ish. I can say 50-ish because they're everywhere from 42 to probably 60, but they're roughly in that 1,100 to 1,200 square foot rooms. And this one here, we have that wall of glass down the back side here because we have that beautiful view off to the harbor there. But again, video is not necessarily about the floor plan, about the view. It's about achieving, this type of environment. And like we talked about there, we did a clear spanning joist, which means the joist goes from that wall to this wall, and it spans the full 22 footish nominal dimension there. All right, and that number there, depending on a lot of these big old open plan rooms, that number probably ranges anywhere from maybe 18 to 24 foot. you know, the nice long rectangular rooms. They zone nicely. You can see this one here. We have kitchen, we have dining space here, and then we have living room space there. So they zone out quite nice, and you know, you can get that kind of center arrangement off of there. Nice open floor plan. You get an entry coming in, and then you have all these views going out to the water there. But let's take a look at here. This is the actual floor framing plan for the project. A couple things about the floor framing plan before we get into the actual joists. You'll see there's obviously some overall dimensions that get placed on the framing plan that just give the framer the sense. I mean, the foundation wall is in. It's not like they're going to alter these, but people need to do takeoffs of floor sheathing and stuff, so they need those dimensions on there. But the important things are, you can see the joists are laid out here. In this case here, they're laid out 16 inches on center. And you can see that's where I pulled from that top right corner, pulled them to the left. You notice that I pointed out we have some solid blocking at third points roughly. And that's basically to help turn what is termed a one-way system. And by one-way system, what I mean is you have a support here, you have a support here, you put a beam across it. Well, that beam spans in one direction and wants to deflect, right? Or bend. Deflect is just a structural engineer's fancy way of saying bending, right? So, but adding some support there and support there that is laterally tied to the next joist and the next joist and the next joist, and then putting floor sheathing on it. Now you have, instead of having this series of beams that are running from this wall to that wall, we introduce this blocking. So not only do you have that bending, but you have the bending in this direction. So the blocking helps stiffen that floor in this direction, and the joists, you know, are trying to stiffen in that direction. So basically adding that blocking helps turn it from a one-way system into a two-way system. And it's not truly two-way in that they're equal. It's certainly stronger in the direction of the joist than it is this way, but it does provide some added stiffness and moves it forward in enhancing the opposite direction, which is the two-way system. But the other information on here, that solid blocking gets called out there. And then here, you can see that is the note where we call out for a 14-inch deep AJS 25 engineered floor joist, right? And the AJS 25 is an engineered I-joist. And so what that means is it has a top chord, it has a bottom chord, and then it has a web member. The web member gets set in to that chord. That 14 inches is the actual dimension or depth. This web member is usually a 3/8 inch piece of OSB, and the top and bottom chords, well, they come in 1.5 inches, 2.5 inches, and 3.5 inches. The AJS 25 designates it as a 3.5 inch wide chord that is 1.5 inches deep. So that means that the web here is 11 inches and it gets embedded inside that chord, probably 1/2 inch or so, 3/8 of an inch. Now, when it comes to flooring, there's a number of different options to look at initially, right? There's the old solid stick,
which is always a good standby, which is the 2x10 or 2x12 typically. Sometimes you can get away with a 2x8 if it's a small span. There is the eye joist that we just talked about. Right. And there is the open web truss. It has a top member, bottom member, and then it has some kind of web member. And that open web truss, right, that is basically looking like that. And it has the web members going through it, and it has the top cord and the bottom cord. And those are usually manufactured, and you can get those in, 9.5, 11 7/8, 14-inch, 16, 18s, 24s. You can use those in floors. We're doing a project where we're going to use some parallel cord trusses, which is what these are, because bottom cord, top cord, and they're parallel, so it's a parallel cord truss. And like I said, those get manufactured to the size, so once they have the foundation in, the gentleman from the lumber yard will come out and actually take some physical measurements, and then they'll go build these so that they're spot on to the dimension that we need. There are some versions where they take the eye joist and mix it with a parallel cord truss at the factory, so you end up with something that's like that, but it has an OSB core before the truss starts. And what that does is that allows you to cut that at different lengths so that you can site modify that truss. So you get the truss, but you get the modification capability of the eye joist. So those are your choices. When you're doing, say, this project here, 22 feet, these are probably not choices, because these are the 2x10s probably go up to about 14, 15 feet. The 2x12s are probably somewhere in a 17 to 18 foot maximum span before you start to exceed their capacity. The eye joists, you can do those well into 30-foot spans, but you're going to get up to members that are, 24 inches deep, etc. And that's pretty much true for the parallel cord trusses and these site modified, open joist or one of those Triforce type products where you can trim it out. One of the things I wanted to talk about before we shut this down is, when you're dealing with a span, let's just say that started out at 16 feet and we bumped it to 22 feet. If headroom for some reason was a problem and we couldn't modify the depth, then what we can do is we can modify the spacing to gain strength, or we can multiply how many members we put in. So we can keep it at the 16 inches and put two members side by side. I think I have a video out there where we actually talked about that on a different project, and that was because we had this height restriction. The other thing is we could take the 16-inch and go down to a 12-inch center, which sometimes we do. But the easiest way to gain strength in any joist system is to take the joist and simply make it deeper. Right. When you're dealing with the strength of the eye joist, inside that formula, the depth of this gets cubed. So anytime you can increase the depth of a floor joist, you get a significant enhancement to the strength. I don't know exactly what the numbers are, but to say go from a 2x6 to a 2x8, the strength isn't just this little dimension. It's like 4 or 6 times stronger than the 2x6, but it has to do with the fact that that depth gets cubed in the calculation. So it helps out immensely by just extending that depth. That little bit gives you a lot of strength. So anytime you can do it, the first order of decision making is, can I make the joist taller? If I can make the joist taller or deeper, then I gain strength that way. If I make the flanges wider, I gain strength that way. If I can change the spacing from 16 inches down to 12 inches, I gain strength that way. If I take the joist and double them, then I get twice the capacity on the same spacing, so I get strength that way. The only other way to gain strength is when you get the parallel truss cords. They can increase the strength and quality of the truss by what those cords are rated as, right? So typically those are, number one, rated wood, right? So it doesn't have any knots. They don't have any checks in them. They're not warped in any way. There's no cracks, no visible defects in them. So they're number one. But you can also elevate that cord to a select or an MSR, which stands for machine stress rated. And that increases the quality of the cords of the truss, which increases the overall quality of the truss, which increases the strength and span capabilities of that truss. So that's kind of your basic 101 on floor framing. The last thing I'll leave you with is, this is just a little architectural feature of mine. Notice that you see the toilet, the sink, and the shower drain, sink drain, although the sink doesn't matter as much as the toilet and the shower drain. And I highlight those in red so that the framer can acknowledge and see that, in fact, we are missing the drains and that the plumber is already been spoken for, in that I ran a check on the toilet, sink, and shower location. And you can see there was a slight modification here with the dimensions. You can see how the spacing got a little erratic here. And the reason for that is it came off the common layout there and the common layout there to something a little more erratic. And that was to fit that shower drain in there. So, that's why we do plans, is to plan for these types of situations. So we don't get out there and the plumber says, hey, where you wanted me to put that shower, when I drilled the hole for the drain, guess what? It fell right on the top of the cord of the joist. Well, we eliminate that by doing a little bit of homework and planning up front. So anyways, that's floor framing for you. Alrighty. That about wraps up floor framing for this week. If you're looking for more, go check out those videos out on the Build Show Network. Been doing this for well over a year. Got lots of great videos out there for you to check out. Once you're done watching all of those, you can see those other contributors: Matt, Wade, Jake, Brent, Drywall Shorty, Mechanical Hub, Design Build Doug, and Zach. Everybody's putting out some great information every week. Always look forward to watching their videos, so go check them out. If you're looking for more from me, you can find me on Instagram, posting daily, putting up details, pictures of stuff that we're working on right today, right at hand. So it's all new stuff. Go check it out. And then last but not least, if you're looking for yet even more, you can find me teaming up with Jake and Peter on the Unbuild It podcast, where we talk about everything building. So every 2 weeks, new episode gets dropped, and exciting stuff. Always a great chat with those guys, and a little entertainment along the way. So go check it out. Steve Basic here. I'm signing off for the Build Show Network. Until next time, long live our buildings.